Honors Practice Problem by Natalie. A skier is pulled up a slope at a constant velocity by a tow bar. The slope has an incline of 25 degrees with respect to the horizontal. The force applied to the skier by the tow bar is parallel to the slope. The skier's mass is 55 kilograms and the coefficient of friction between the skis and the snow is 0.120. Find the magnitude of the force that the bar exerts on the skier. So let's break down what the problem is trying to ask you. If the skier is pulled up a slope at a constant velocity, that is something that you should notice. Also, it has an incline of 25 degrees. The mass is 55 kilograms, and the coefficient of friction is 0.120. Those should all be things that you should write down. Also, figure out what the question is actually asking you, which is to find the applied force. So let's look at our skier. Right here, he's being pulled up by an applied force. The normal force is being exerted above him, force of gravity is pulling him down, and the force of friction is working against him. That was a very basic force diagram, so let's look at one that's a little bit more complex. If we pretend that this is the skier at 55 kilograms, we have to remember that the normal force keeps going through, which makes an angle right here. Keep in mind that the angle here is equal to the angle of the slope of the incline. So these two are equal. Also remember that this angle right here is a 90-degree angle.
If you notice from your force diagrams, you can see that the net force in the x direction depends on the applied force by the tow rope minus the force of kinetic friction minus the force of gravity's x component, and that will cause the mass of the skier to accelerate. If you look at the forces in the y direction, that's the normal force minus gravity's y component equals m times a in the y, which is 0. Also note that the force of gravity is mg and the force of friction is mu times the normal. Now pause the video and give it a shot.
Alright, let's work it out together. The first thing we need to know is the force of gravity, which we know is equal to mass times the force. So the force of gravity is going to be equal to 55 kilograms times gravity, which is 9.8. This equals 539. That's important. Remember this diagram? Now we're going to use it to find the force of gravity in the x direction and the y direction. Now that we know that this is 539, we can use sine and cosine to find it in the x and y directions. First thing we're going to do is we're going to find the x direction. We're going to use the sine of 25, which is equal to x over 539. This is going to give you the force of gravity in their x direction, which is going to equal 227.79. Then we're going to use cosine to find it in the y direction, which is going to give you the y direction of the force of gravity, which is 488.5. Remember this equation? This is the next one we're going to find. So we need to know the force of kinetic friction. And to find that, we were given mu k, which was 0.120, but we don't know what the normal force is. But we actually do. The normal force is equal to the force of gravity in the y direction, which means that the normal force is equal to 488.5. So we can plug that into our equation and get the force of kinetic friction, which is going to equal 58.62 newtons.
Just note that the normal force equals the force of gravity in the y direction from doing our net force in the y.
Now we just need to put it all together. This is going to be our final equation so that we can find the applied force. We can leave that one, and we can subtract the force of kinetic friction, which we just found, 58.62, and the force of gravity in the x direction, which we also found, 227.79, and that's all going to equal mass times acceleration in the x direction. Now you may be wondering why we didn't find the acceleration, but the truth is we did. The velocity is constant, which means that our acceleration is equal to 0, which makes this whole thing 0, which means that we can move our other variables to the other side. So our applied force is actually going to equal 58.62 plus 227.79. Our applied force is going to equal 286.41 newtons. That is your final answer.